Hi and welcome. I'm trying to learn space science. Today we Oort, cloud and comets. And after we've done that, we're going to do stretching. And if you participate in the stretching, then it's better at your own risk. Okay, we're having here a chapter about comets, and now we want to focus first on the Oort cloud. I don't know how it's pronounced. It is written O-O-R-T. Okay, some comets, like the Halley comet, have short orbits, circling the Sun every few dozen years. Others take thousands of years, spending much of their life at great distances from the solar system hub. To astronomers, this suggests that long-period comets hail from a vast spherical reservoir known as the Oort cloud that surrounds the solar system. It is perhaps 100,000 astronomical units across. If it exists, as seems likely, the Oort cloud could be home to trillions of inactive comets. Now, inactive comets, I think they don't mean that literally. I think they mean they are there, but they take very long to come back. But not that they are standing forever like that. Otherwise, that wouldn't be comets. Okay, the Oort cloud. Here's written it surrounds the solar system. So the Oort cloud is not in one place, but completely. So there's the Sun with the 8 planets, and then there is the Oort cloud around it, and also like that probably. I don't know. I'm gonna stay like that. Okay, it is 100,000 astronomical units across. One astronomical unit is 150 million kilometers. So the thing is 100,000 times 150 million kilometers big. How big would it be if it would be written down? One astronomical unit is the distance from Earth to the Sun. So we would have here the Sun, and then not here Mercury, Venus, Earth, but they would be already further away, I think. So that we're all more like here, Mercury, Venus, Earth. And then all the planets here. Now, if it thinks on 100,000 astronomical units across, it would not be a little thing at the side. It would be then here the Sun, then somewhere here, Mercury, Venus, Earth. And then, now it would be one astronomical unit if the Earth is here. It would be 100,000 times that distance somewhere out here. 100,000 times that thing. That means that as a model would look like that, where would it be the Sun, and where Earth, and then something like 10 football fields, the Oort cloud. Okay, the Oort cloud is an idea of a vast place. It's not completely clear if it exists. It exists maybe around the Sun as a big place with a diameter, with a size across of 100,000 astronomical units. That is, and one astronomical unit is the distance from Earth to Sun, 150 million kilometers. And that is a place where it is assumed that there are some comets who come only every millions of years once around the Sun. Comets going around the Sun, I'm rehearsing right now, comets going around the Sun in elliptical orbits. There's the Halley comet, it returns every 76 years. It has quite a short back appearance. Short appearance rate. It comes every 76 years in elliptical orbits. Now the other comets which come way more seldom are assumed that they maybe they're out there in the Oort cloud. In the big Oort cloud, and they come only every millions or billions of years once around the Sun, if at all. Okay, that is the Oort cloud, and I think we have information we have to it. I'm going to start the second camera, and I try to set it. The Oort cloud. The Oort cloud, if it exists, is outside of the universe. Now there's the Sun, and then the 8 planets, Mercury, Venus, Earth, and then Mars, Jupiter, Saturn, Uranus, Saturn, and Neptune. And now there's the big Oort cloud, maybe if it is there. And in that Oort cloud there is the assumption that there are many comets. Comets have big orbits in an elliptical form, so not a circular, but elliptical. And there is the Halley comet, and that Halley comet comes around the Sun every 76 years. Once around the Sun, every 76 years. But there are other comets who come only every thousands, millions, or billions of years probably. And it is the assumption that there may be out there in this big Oort cloud around the solar system. And that is according to Mark A. Garlick's Cosmic Menagerie book, page 27. Awesome. I wanted to say something. I'm going to stop the camera. Did I say the thing with 100,000 astronomical units? No comments for a second. I forgot it. When we have to remember it. Okay, comets. We're going to say the example with the Halley's Comet, discovered by William Halley. And they're orbiting strict periodically with the Sun in highly elliptical orbits. And asteroids spelled between Mars and Jupiter, they are more rocky, stony, metallic. These other one comets are icy shanks, with great and riddled with holes. And they are also smaller, a few hundred meters, a few kilometers, a few 10 kilometers. The asteroids can be bigger. The biggest one, Ceres, was 950 million kilometers. And they are not good visible when they're close at the Sun, then they are so close at the Sun because they are elliptical, not round around the Sun. The ice boils, enshrouded in a cloud, the coma cloud, and two forces of the Sun act into it, the radiation pressure, directly the sunlight itself pushing the cloud out into space millions of kilometers, and also the solar winds. These are subatomic particles blustering outwards from the Sun, pushing the tail behind it. That's why known as shooting stars, and that is a hallmark of a comet. And it is the assumption that some are back out where the Oort cloud, which is 100,000 astronomical units across. I'm going to start the camera again and stretch it. Comets. Comets are basically big stones which are flying in the universe in the solar system around the Sun. And they're having not circular orbits, but huge elliptical circuits. So like that are they going around the Sun. Yes, the Sun. Like that around the Sun. And there's one comet, for example, the Halley's Comet. And that comes every 76 years once around. And it was discovered by William Halley. And he was looking at people who had written down something and said when they saw them, and he calculated that is every time the same one which was seen, not a different one. And then he said it will come again then that year, because he found out they are every time periodically. They are coming exactly every 76 years. Now these Halley Comet, every 76 years. There are other comets who come much more seldom. Now comets are a little bit different than asteroids. Asteroids are mostly between the asteroid belt between Mars and Jupiter. There's Earth and Mars and Jupiter. And they are closer to the Sun, and they are more rocky. They have more metal in them, and more stones. These comets, they are with ice and grit and riddled with holes, and they're also smaller, just a few 100 meters or a few kilometers. The biggest asteroid is 950 million kilometers in the diameter, Ceres is that. Now, in these comets, they are further out, and there is the idea that outside of a space, there is the Oort cloud, called like that. And behind all these planets, there's then this big Oort cloud. It is 100,000 astronomical units across. One astronomical unit is 150 million kilometers, the distance of Earth to Sun. Now, a big 100,000 astronomical units, big Oort cloud, and there are maybe many comets, but they're coming only every billions of years or whatever around the Sun. Not like the Halley Comet, every 76 years. Now, and if comets are close to the Sun, then they are leaving its tail behind it. Now, it happens like that. They are close to the Sun, and because they're going elliptically around, so they're far away and then close to the Sun. Far away and then close. And when they're close to the Sun, the ice of these comets boils and then shrouds the comet in a cloud, the coma cloud. And now two forces of the Sun pushing it out into space and leaving the tail behind it. There is the radiation force, that is the sunlight itself basically pushing it out, and also the solar winds, subatomic particles blustering from the Sun out, and they're pushing this tail behind it, the hallmark of comets. And these are comets. And that is according to Mark A. Garlick's Cosmic Menagerie book, page 26 and 27. I'm going to stop the camera. And I think I said it all. I almost forgot the whole thing with the Oort cloud. And that was the space science part, and I think that was it so far for comets. In the next part, we will continue then with the next thing, probably in this book, which will be exoplanets, new word, or something else. Whatever. That means that was the space science for now. We'll continue the next part with space science. If you stay here and participate in the stretching, then it's at your own risk. We are having the feet standing together, and now open one foot to the side, and we are going to the side. Again to the side, now with the toes again, and with the heel, and with the heel. Controlled, slowly, as far as you can go, and now we're coming back in again. But you stay down with the head, so go into the knees, stay down with the head. Stay down with the head, and we've closed. That was the rooting tree exercise. Now to the next exercise. The next is standing shoulder wide apart, and we're breathing in and lifting the arms up. And breathe out, go one side. Breathe in into the middle, and breathe out over to the other side. In into the middle, and out with hands down. Now breathe again in, and out one hand slides down the leg. Now one sees the abdominal exercise. The other shoulder stays down. Breathe again in, and out one arm over. Breathe in over the rib cage, and breathe out back into the floor. Breathing in, and out with one hand slides down the leg, and the other shoulder stays down. Breathe again in, and out one arm over. Breathe in, and out back into the middle. Next exercise, the aeronautic, aerobatic, aeroplane. The feet are standing together, you're breathing in and lifting the arms up. And breathe out one hand down. Breathe in and reach. And breathe out hand up. Breathe in, reach high. And breathe out one hand down. Breathe in and reach. And out other hand up, hand above down. Now next again, shoulder wide apart a bit more, and we're doing shoulder circles. Breathe in, go back with shoulders up, in front and down. Again back, in front and down, and in front, up, back and down, in front, up, back and down. And now breathe in and lift the shoulders up, and out and down, in and up, out and down. And breathe in the thumbs up. And we're doing the apple plucker. Reach always with one hand high up. Pretend to take an apple hanging high on an apple bunch. To turn it a bit around and then to plug it out. And now the shift up. Legs wide apart. Arms up to a T. Breathe in. And breathe out, go over to one side. Breathe in into the middle. And out over to the other one. Again in. And out, lean onto the knees. The buffalo fighting its hangover exercise. Breathe again in. And out one shoulder in front. In the back. Out the other one in front. In the back. Out in the front. In the back. Out the other one. In the back. And out into hanging down. Niagara Falls. Just keep hanging down. Breathe again in. And out, go over to one leg. Breathe again in. Out over to the other one. Breathe again in. Out into the middle. And close the feet. The Salto Angelo exercise. Breathe again in. And out. And again in. And out, come with a round back, slowly up and back at the top, backward shoulder round. Legs wide apart, and the toes pointing to the outside, having an alternate space between the heels. Breathe in, lift the arms up. And breathe out and sink down into Carlin pose. Elbows against the inside of the knees. Breathe in, straighten up. And breathe out and come with the back up. Breathe in. And out and down. Breathe in, straighten up. And out and come slowly in one straight line upwards. Hands down. And we're closing with a trunk igniter, legs wide apart. Breathe in, go down. And breathe in, out. In and up. Out and down. And breathe in, close the legs. And breathe again out. It was a stretching. I thank you very much, and until next time.